All right, so I think I'm recording here. Let's take a look at this problem number 4. They want us to find the inverse and then to determine if the inverse is a function. So the 6 over 2x minus 1 minus 3, you may not be as familiar. In the previous problem, we were familiar with the original function because it was a line. Well, here, this is transformations on a reciprocal function, but you may not be aware of that. So we're just going to jump in and use the technique of switching the domain and range, which means switching x and y. So we're going to write this equation as y is equal to 6 over 2x minus 1 minus 3. And now we're going to switch x and y. And then we have to step by step try to solve this equation for y, get the y by itself. So let's add 3 to both sides of this equation. And some students may decide to cross multiply. So if I multiply along the diagonal here, then I have the x plus 3 times the quantity 2y minus 1 is equal to 6. Now remember, we're trying to get y by itself. So even though the temptation might be to multiply these two binomials together, you're going to be better off if you recognize the second factor contains the variable that we want and actually divide both sides by this binomial by x plus 3. So if I divide this by x plus 3, I have to divide the other side of the equation by x plus 3. And x plus 3 divided by x plus 3 is just 1. So on the left-hand side, I have two terms, 2y minus 1, and I have 6 over x plus 3 on the right-hand side. Well, now it's going to be easy for me to get this y by itself in just 2 steps. Add 1 and divide by 2. So if I add 1 to each side, then I have 2y is equal to 6 over x plus 3 plus 1. And now if I multiply both sides of this equation by 1/2, then I'll have the y by itself. So on the left-hand side, the reciprocal of 2 is 1/2. That's why I chose 1/2, is because when you multiply by the reciprocal, that product is just 1. So now I have to multiply the right-hand side by 1/2. And I'm going to continue up here. So on the left-hand side, half of 2 is just 1, and I have my y, which is what I wanted. I wanted to get y by itself. Now, on the right-hand side, I have two terms. Both of these terms are getting multiplied by 1/2. So when I come in and multiply the first term, 6 divided by 2 is 3, and I have 3 over x plus 3. And then when I multiply the second term here, plus 1 times 1/2, that's just plus 1/2. So now I have my inverse, and I want to try to decide is this a function or not. So there's a couple of things to kind of think about. If you think about the graph of this function and plotting points, as you pick different values of x and plug it in, and you do this arithmetic, for each x, you're going to get exactly one y value. When I plug in 0 for x, I have 1 plus 1/2. I have 3 halves, and you can do that and pick numbers as long as you don't pick -3, because that would cause division by 0. But any other x value that you pick, you're going to get exactly one y value. And think about the definition of a function. For every element in the domain, the function relates that element in the domain to exactly one element in the range. Okay, and another thing is that we have these kind of rule of thumbs to look for. I don't see any absolute value symbols around the y, and the exponent on the y is odd. Okay, so this is definitely a function. Because for each x in the domain, you're going to get exactly one y value. You can just keep on plugging values here and do that arithmetic if you'd like. Let's use function notation. The original function was called g. So now that we know that this is a function, we can write it in such a way that people will understand the relationship between this function and this function g. They're inverses of each other. All right, so I hope that helps, and I'll talk to you later. Bye.